Okay, so in this video, I will be going over the 2011 APCSA FRQ, problem 1. Digital sounds can be represented as an array of integer values. For this question, you will write two unrelated methods of the sound class, and they give a partial declaration of the sound class. They hide the constructor, which is really common because they don't want to confuse who's taking the test, and they want to direct the importance towards the two methods of the class, which are limit amplitude and trim silence from beginning. So right now we can just see their signatures and their preconditions and postconditions and what parameters they take in. And we can also see the field variable, which is an array of integer samples. Okay, so question A is the volume of a sound depends on the amplitude of each value in the sound. The amplitude of a value is its absolute value. For example, the amplitude of negative 2,300 is 2,300, and the amplitude of 4,000 is 4,000. Write the method limit amplitude that will change any value that has an amplitude greater than the given limit. The values that are greater than limit are replaced with limit, and the values that are less than negative limit are replaced with negative limit. The method returns the total number of values that were changed in the array. For example, assume the array samples has been initialized to the following values below. So the following values below in their example is 40, 2,532, 17, and so on. And the method is going to return an integer value representing the number of times we changed an element in the samples array. So although we are returning that, we also have to be changing the samples array in the execution of this method. So for example, let's say the limit is 2,000 over here. 40 is in between negative 2,000 and 2,000. Therefore, it does not change. And this is the array resulting from the execution or call of this limit amplitude method 2,000 with the parameter. So 2,532 is greater than 2,000, which means it's changed to positive 2,000. 17 is in between negative 2,000 and 2,000, so it remains unchanged. However, negative 2,300 is less than negative 2,000, so it gets changed to negative limit, which is negative 2,000. So you keep doing this, and what you have to do is also keep track of the number of changes you do. So for example, this here is one change, this here is another change, this is another change, and so on. You just keep track of that. And they give the signature of the method, prompting us to write our answer, and they give the description of what this method should do, and all the postconditions, preconditions, anything we can assume, and what we should return. Okay, so let's get to the solution. So the first step is write the signature of the method with the parameter limit, and what we're always going to do is before looping through or traversing through the samples array, we're going to keep track of the number of changes. So we set that number equal to 0 at first. All right, so then we're going to be looping through or traversing through the samples array. And this is called a for each loop, which basically allows you to not worry about the index, rather just the element accessed directly from the array. So sample, in this case, could be sample 0 or sample 1 or sample 2, all of that from samples until dot length minus 1. So in the loop, we have to check if the individual element of samples array is greater than limit. And if it is, we have to replace that sample with limit, which is what we do here, and then increment the number of changes. But we also have to make sure that we're doing the same thing for negative limit. So if the individual element here is less than negative limit, we change that element's value equal to negative limit, and then also increment a number of change, because these two are two types of changes. Then all we do is simply return the number of changes. And that would be our first method. Okay, so part B is a little more complex. So recorded sound often begins with silence. Silence in a sound is represented by a value of 0. Write the method trim silence from beginning that removes the silence from the beginning of a sound. To remove starting silence, a new array of values is created that contains the same values as the original samples. array in the same order but without the leading zeros. The instance variable samples is updated to refer to a new array. For example, suppose the instance variable samples refers to the following array. So this is basically another example of the samples array. And all we have to do is basically trim out the leading zeros, which is this here, 2, and 3. So everything in the place of index 0 to 3, we take it out and leave everything the same. And we're not returning anything because samples array is the field variable, which means we don't return it. It's fully accessible to the entire class. So then the result should be this. So your logic should be, how can we remove these following zeros? Well, let's get to that in the solution. And here they're prompting us to write our example or write our solution for trim silence from beginning. They're giving the preconditions and postconditions, any assumptions, and basically a description of what the method should do. Okay, so at first you need to start off with the signature as always. This is a void function, so it does not return anything, and it does not take in any parameters because it just solely depends on the samples array. Okay, so now what we're going to do at first is copy all the elements of samples into a list of integers. So sample list is basically the same thing as samples as of now, except in a list. And at first we initialize or we create a list which is completely empty. Then we traverse through the samples array with the for each loop and add each element of samples, which we're calling sample in this case, an individual sample. We add it into the sample list. And by the end of this code, sample list has the same values as samples. It's just in a list format. All right, so the next part of the code is to look at the samples list and remove all the leading zeros, which is what we do. So same thing here. We're going to be traversing through the loop, except in this case, we need to know what the index is. So we start off with index equals 0 and go up until the list's length, and we increment index every time. So for every time we loop, we have to check if the element of the list is equal to 0. If it's not equal to 0, well, then we break. We come out of the loop because we want to leave the rest of the array completely untouched. But if the value is 0, then we first have to remove that sample, and we do that using the .remove function of a list or array list and pass in the index, which tells the array list to remove the element and shift all the other elements after it down by 1, which is why we do index -1. So we decrement the index to keep it so that the loop stays intact. And this code here basically takes that array list, which is everything the samples initially has, and then removes the leading zeros and leaves the rest of the list completely untouched. So now we have the values except in a list, which means we have to convert this list back into array form, or back into samples at least. So here we create an array called new samples, and we initialize the array so that it has a length of sample list.size. And we do this because we don't know how many zeros there are or how many we're removing, but we do know the size of sample list after removing the zeros. So that's what we're going to do. And now we have to traverse through the sample list array list and copy all the elements from this list into new samples, which is what we do here. And then once we have new samples, which is the result that we need to get those values into samples, because the whole point of the method is to take out the leading zeros of samples, not new samples. And new samples is just a temporary local variable that we created in this method. So then after that, samples and new samples are both integer arrays, which means we can perform this operation and using the equals operator, just copy all the values of new samples into samples. So now when you call the samples object, it points to or refers to the values of new samples. And that is it. There's no return statement because this is a void method. Thanks for watching.